this video, we'll be talking all things kiln, how to load and unload, as well as how to program, what is a firing ramp, and we'll also discuss things like heatwork and pyrometric cones. So a little bit about loading a kiln. When you are loading, depending on the size of your kiln, etc., you will always be using stilts. They might be of different heights and sizes, but usually they will look quite similar to this shape. Of course, depending wherever you're based and also on the manufacturer of your kiln, you might have slightly different looking ones. Traditionally, you will have 3 to create the best balance. In some situations, maybe like wood firing or soda kilns, etc., you might be using 4 stilts, but that is quite rare. Best stability in electric kilns usually is achieved with just 3 points, and then you'd be placing your kiln shelf on top. Here, because it's quite a small kiln, and I'm just demonstrating loading a few test tiles, as I have my kiln only at 20 liters. I don't require any more stilts as I'm not going to have an extra shelf. So if I am loading glazed ware compared to bisque ware, I want to be allowing sufficient space between the items to make sure that they're not touching. There could be a millimeter or 2, but this will be really affected by the type of glaze that you're firing. Say if it's something like any of gloss glazes, like lava glazes, for example, they could have a nature where they start expanding and growing, and they could attach to nearby objects, so you want to allow for more space. As well as if you are placing larger objects compared to those smaller test tiles, maybe there's even a bit more room and even more caution in terms of having the base completely clear of the glaze, right? So we never glaze or we wipe or we use a resist of some sort on the base, and we allow plenty of space. Versus if we're bisquing, our first firing, we might even stack things together, they might be touching. Sometimes when I do these test tiles, I even shape them in such a way and create a kind of layer cake to maximize the space that I'm utilizing within the kiln. But the glaze firing never allows for that. If we are experimenting with new unfamiliar glazes or trialing recipes, then we want to maybe take extra precautions for kiln shelves, right? Because they are covered with kiln wash, batt wash, otherwise called, to help us save the kiln shelf itself. But maybe we also make some throwaway, basically kind of setters or danger discs, they're called sometimes. This is just made out of recycled clay that we can place underneath our test tiles. So if they were to run loads due to unknown factors, maybe the recipe itself, we wouldn't be quite disappointed in ruining our expensive kiln shelf. Alternatively, we can also use, whether on the danger disc or on the kiln shelf directly, items such as silica sand or alumina hydrate, just to have extra protection. These are also good solutions for more experimental sculptural glazes. So when unloading the kiln, you want to check the temperature as well as the feel of the kiln and the works. If your works are still a little bit too hot for touch, maybe above 50 degrees or even in that region, I highly recommend using a protective glove that's heat resistant so that you make sure you don't burn yourself, and then you could maybe place the slightly hot pieces on the rim of the kiln, because the refractory brick still will sort of help us protect the environment around. Don't put it on top of flammable wood materials like textile maybe or plastic, and then they'll cool down enough so that we can transfer them and we can unload the kiln. I also recommend, especially at testing stages, to use pyrometric cones to measure not only the temperature of the firing, but also heat work. And we'll talk about cones in a second and what they do. A lot of people wonder how to fire the kiln itself, how to settle on a program, on the firing ramp, and what segments and what temperatures it should have. There's a lot of diverse information out there in terms of how to fire, whether it's bisque or stoneware or earthenware firing, and you will hear a lot of different, sometimes even maybe conflicting information. I will run you through a few programs and how I fire in my Rode kiln. This is quite a small 20-liter kiln, a test kiln really, only suitable for small work. The complicated thing about all this is that there's not really one simple answer, that this particular glaze, this particular kiln has to have an exacting firing, because there is multitude of factors that will affect how you run your program. Possibly it's the literage of the kiln, so a kiln that's 20 liters versus 100 liters will require different programs. If you're firing plenty of thin thrown plates versus one singular coil-built crank sculpture will affect how you fire that exact same kiln and the type of glaze that you might be working. Even if we are staying within stoneware range, it might affect it. So let's go through one program of mine that I test quite a lot of recipes at. Here we have the program number, and then we have the ramp. So this is the first segment. A lot of controllers will have segments, and there might be two different ways that they calculate it. In Europe, majority of them calculate how many degrees are per hour. So how fast is the kiln climbing? There are some other controllers that might switch that and ask you how many hours will it take you to reach the temperature. Because the next thing in our program after the degrees Celsius per hour is the actual temperature that it's reaching. So it will be going at a rate of 150 Celsius per hour to 1124 Celsius as the temperature, yeah? And that's why we see this dot light up now compared to this arrow here. And then this segment, which is quite common in a lot of controllers, it's how long is the dwell. What is a dwell? It's a kiln sitting at a particular temperature for a while. So it also is called a hold, and at the end of the firing it's called a soak as well. So it's basically trying to maintain the same temperature, the same number of our controller. So if we go through it again, we have Celsius per hour, 150 to reach 1124 in this case. Then we don't hold this temperature, we skip to our next second segment. This segment is much slower, you can note, is 60 degrees per hour, and it reaches 1235 Celsius as our final temperature. Afterwards, we do add, because it's quite a small kiln and I just want to unify it a bit and maybe reach something equivalent to 1240, right? I let it soak for 5 minutes before the program is complete. So currently it consists only out of 2 segments, and the third segment is already on the downward cooling, because you could be programming cooling segments for very specialist glazes like crystalline glazes, for example. But this controller only tells us points of temperature. It doesn't actually measure something much more complex about a kiln firing, which is called heat work. And for that we need pyrometric cones to have another mechanism to check in, to verify has our kiln actually reached that temperature in terms of heat work accumulated in the chamber, or is it just a number that the thermocouple is reading. So what are pyrometric cones? How do we use them and why do we need them? So generally what's available currently on the market is Orton cones, and that's as well how they might be titled in your shopping list or when you read about them online. And Orton is the manufacturer in the United States. They come in different numbers, which usually you should be able to read on the side of the packet. And here we've got 7, 6 and 8. So in fact, they should be arranged like that. The box supplies quite a few cones and they come in a sort of glued fashion together. A box on average in the UK costs in the region of £50 or more. So they are quite pricey things, and when you are starting to test, you might want to just buy a selection rather than a whole box straight away. And then you have to sort of break them apart. If you are damaging them when you're breaking and the tip is gone, then I would highly recommend using a new cone, because it's not going to give you the reading that you require. There's also a new addition from the brand, from Orton, that exists now, which is called self-supporting cones. So normally when you are creating a cone stack, majority of the traditional stacks will contain 3 cones together. and it's usually the cone in the center that you're aiming for. That's the temperature we're trying to reach, versus the first cone in line is a kind of checking point whether we have surpassed, whether it's underfired or not. And then the final one is sort of to tell us, have we overfired? Have we maybe gone a little bit over? But whilst I'm saying temperature when talking about cones, that's not really what they're actually measuring. They are measuring something called heat work. And simply heat work is temperature multiplied by time. If we just allow ourselves to depend purely on the number on the controller that the thermocouple is providing, we are missing a big part of the picture, because the glazes themselves don't really, sit and wait for the temperature to hit and then flux and melt. They actually require a certain amount of time to accumulate heat within the chamber, within the object, within the glaze itself, for the glaze, which is a chemical reaction awaiting to take place, right, to happen. Time is required. And here we can really think about baking or even cooking a roast, etc., right? Whilst our oven might be saying, say, 200 degrees at all times, right, if we haven't switched it off. But I've put my meat roast for 15 minutes at 200 degrees, and I've also put my roast in the oven for 5 hours at 200 degrees. Sure, the temperature on the controller of my oven will say exactly the same number. However, heat work that affected that roast is completely different, and my meat is going to be not cooked at all versus burnt, right? So that will be a huge effect. Same goes for glazes. And what are these cones measuring when we talk about heat work? Generally, they're measuring the final 100 Celsius, I'm talking about here, final degrees of the firing, and how are they achieved. You will see in additional documents and reading material the chart to compare the cone number to the actual temperature, both Celsius and Fahrenheit. And also do look up at the top and check what is the degree rate per hour that is recommended. Because if you are not following that rate, the reading of your cone might not be right anyhow, right? So just to reiterate, we are measuring heat work that the glaze is going through. We are generally concentrating on measuring the last 100 degrees of the firing, because that's all kind of where all the magic happens. And to aid us in understanding what cones really are, in a way we can think of them as glazes themselves. So when they were invented, again, do refer to your extra reading on their invention and use in the industry. They have been formulated just like a glaze itself. So in a way, you could take a cone, crush it up into a powder, and create a surface out of it. And they are consisting out of exactly the same materials we are formulating our glazes with, right? The silica, the alumina, and the fluxes. That's what's inside the cone, but in such a proportion that they're targeted to bend and create a very particular curve that you can read with the Orton manual diagram to say whether we reached the temperature, whether we surpassed it by 10 degrees, etc. So just to conclude this part on cones, now we know that they're pretty much glaze combination themselves, but just very targeted for a particular temperature. They help us measure not just temperature itself, but heat work. So temperature multiplied by time taken to achieve that temperature. And also they are a way to check in not only whether our glazes are performing correctly, but also to check whether the kiln itself is performing correctly. Because over time, within the kiln, the elements are aging pretty much with every firing. The thermocouples are degrading as well, especially the majority of the types of thermocouples we have in our hobby kilns. So over extensive use over the years, you might notice that your controller says the same number, however the firing results are inconsistent with that. And that's where checking in with the cone to then be able to alter the firing ramp is the way to use the cones.